So, hi, I'm Lars. I'm from Elastisys, where I work as a software architect. And this talk is about auto-scaling in a multi-cloud environment, such as City Cloud. So, imagine that you have a 10-fold increase in users. Are you happy about this? What are your feelings about this? If you are in marketing and sales, this is probably you. You're really happy about it, because this means you've done your job and it's starting to pay off. If you're in operations, maybe it's not so comfortable for you. I don't know. A 10-fold increase in users is kind of difficult to deal with. Could be, at least. And you might be fearful because you know that if something is screwed up, everybody will be really mad at you. Whether it's the servers or if it's the cloud that fails. So, and also users. All those users that wanted to see your site, now they can't because something failed. Now this problem, so my goal for you is that you'll be able to deal with this calmly. I want you to have Buddha-like experience, like, oh, we have 10 times more users. Awesome. This is my goal for you. The problem is not new. It's actually rather old. This is from the 1998 World Cup. This is what the web server load looked like at that point. When interesting games were played, this is the increase they had. Very rapid. So how did they deal with this? Well, it was 1998. We didn't have clouds. We didn't have anything of that sort. So they just used tons of servers, which in 98 terms was 30. But tons of servers. And they were always on. And if something broke down, there wasn't really any automatic way to fix it. You had to do it by hand. That's the old solution. Now we have the cloud, and auto-scaling is the solution, of course. So, auto-scaling, if you don't know, is about adding and removing servers from a pool based on your demand. And multi-cloud auto-scaling is the same thing, except now you're involving multiple clouds, or, as is the case in City Cloud, multiple regions or zones within a single cloud provider. So why would you want to use auto-scaling? Well, first, it's the obvious argument about cost savings. This is the one that first comes to mind because it's so obvious. If I can scale down when I don't have any visitors to my website, of course I'm going to save money because I'm not paying for servers that I'm not going to use. I would argue this is not the most important one. I would say that peace of mind is what really matters. That's what I care about. I want you guys to have peace of mind when you deploy an application to the cloud and know that it's going to have the right amount of capacity allocated to it. It will leave you with more time to enhance your service, because if your business is not unique in its ability to run web servers and to manage them and keep them operational, if that's not what makes you unique, maybe you should try to automate that away as much as possible so that you have more time to actually do what matters to you and to your customers. Your service deployment is more robust because if something fails, you can just terminate that server and a new one will come up immediately. And the whole point of having an online service is that you want to satisfy whatever user needs users have. So increased customer satisfaction because your service is more responsive and always appears to be perfectly provisioned. We have a case study. Can you see this? Yes, you can see this, roughly. With a company called Clarobet in up in Umeå, where we're from. We helped them implement auto-scaling. I don't know if you can see the numbers here on this graph, but they have a cap on the amount of servers on 200. So they run between, say, 20 or so and 200 or so servers. Now, if they would do static provisioning, they would have to have 200 servers always on. Since we're doing autoscaling for them, they have about 55% cost savings just without having to do anything at all, really, from their point of view. Peace of mind-wise, which again is what I think is the most important aspect, we have this quote from their CFO and lead developer saying that we feel very confident in the Elastisys solution, at times even forgetting that we have a lot of virtual machines running in the cloud. Everything just works. Does that sound like a stressed man to you? Not to me. I'm really happy about this, because that means they can focus on their core business, delivering a service to their customers. They don't want to do server administration. It's a necessary evil for them to have to do server administration. So before, they were actually spending hours every week just logging into servers, making sure stuff worked, replacing software, doing all kinds of manual stuff. Now, they're down to minutes per week because we're doing auto-scaling for them. That's useful, especially since Clarabet has 4 full-time employees. So any time spent not just developing their service, wasted. So how do you configure this? Is it difficult to achieve this stuff? Well, first of all, I've made some preparations in true TV chef manner, right? So I've created a load balancer with a floating IP in CityCloud. Now, that's why I asked about the load balancer when Kim was giving his talk. The load balancer there is right now not like super awesome, but it's definitely getting there. I've created the credentials that I need to log in using the OpenStack API in CityCloud, because your normal username cannot do that. And I've also registered SSH key pairs and stuff in OpenStack so that I can use them from the API user. Boring technical stuff, but if you care about this, we have a video on YouTube showing how you do that stuff. Right? So then, the auto-scaling configuration. And it looks like this. Now, because this projector has such a low resolution, you're actually going to see what it looks like if you use like an iPad or something. Because the website is responsive, right? So it's really huge right now. It's not really my intention, but I can't make it any different. Anyway, you select which zones you want to use. Here's the Kuna zone. London is not in use, and Stockholm is in use. Now, I've prioritized these differently so that I want a certain percentage of my deployment to be in one zone and a certain percentage to be in the other. And then I also configure some kind of failover, so if a zone fails, what should happen, right? So that's what I've set up here. So priorities and wait times. How long should I wait for a server instance from a certain zone before just declaring that zone broken and going to the other one, right? Now, since we're starting servers, we have to define what does a server look like. So we have to define some kind of template. What size does it have? What boot script do we use? Security groups, etc. If you've started a server in CityCloud, you've already answered these questions at some point. Our user interface looks a bit different, but I choose like a 1-core, 1 GB of RAM instance, base it off of the latest Ubuntu LTS, like a default security group, the demo keys that I said before, and then I have this user data section that just updates packages and installs Apache web server and makes a stupid web page that's supposed to be funny. It's going to have a result that looks like this. So it's going to be a cow that says something wise, you know, the fortune command if you're a Linux nerd. And each instance will then have its own like unique cow and unique thing here in the title. Then we just say, what load balancer do we want to use? And it's a bit broken here, sorry. There we go. We see here that we can select which load balancer to use. And since we're running in 2 zones, it has to use the public IP addresses of these server instances, because otherwise the load balancer sitting in one zone would be unable to actually distribute load to like server instances running in another zone. I tell my autoscaler how many requests per second coming into that load balancer that I think one server instance can deal with. And in this case, I'm going to set that number to 20, which is of course ridiculously low, but this is just so we can easily overload it. We have Apica in the room, right? Awesome. Can you please start something horrible against cloudbeer.elastisys.com? Can you please do that? Do you have your computer with you? Yeah. Because if not, I want everybody who has a phone or a computer or something to actually go do this. Because every request against cloudbeer.elastisys.com will maybe enlighten you with whatever the cow here has to say, but it will also create load against my auto-scaled application here, which will cause it to scale up. And that's kind of funny. So I set also limits for minimum number of servers and maximum number of servers. And I've set that number to between 1 and 100. So we should be able to see some interesting scaling here. That means 2,000 requests per second, but yeah, I think you guys can do that, especially Apica. If I want some alerts, I can configure either emails or webhooks so that I can integrate with, say, PagerDuty or something, so that I can post the message to a certain API endpoint and say it's an error message and I post it to an API endpoint and then that reacts. If you want to automate this further and have this be part of an entire ecosystem of stuff that you're using. Right, but as I've already sort of shown here, I started my own load script already before I came on stage, so that's why I have more than one server responding to these requests. If it looks like it's just one, it's actually not. It's just that there's a round robin thing going on in the load balancer. Don't worry about it. We have tons of these. So to see how many we actually have, this is not very many. We need Apica to torment this server a bit. We'll come back to that later in the talk. Do you have any questions so far? Then please interrupt me, because I think questions related to whatever the presenter says maybe helps more if you ask them.
Can you do some intelligent scaling, not just like request limit or something? Can your nodes actually report when they're under heavy load?
Oh yeah, sure. We can scale based on anything that you put into a monitoring database. And right now we're based on OpenTSDB. So you can use the T-collector agent if you want on your servers. So if you have a custom metric that matters a lot to your application, you can report that in, and then you can configure our system to base its auto-scaling on that. This configuration webpage here that I've shown, that's just to get up and running for like the most normal case of load balanced web application. But we can do auto-scaling for anything basically. We have a full REST API. It's you can only access via HTTPS, and we do HTTP basic authentication under HTTPS, which of course you're going to say that sucks, it doesn't help at all, but yeah, it's probably crap, but it's cloud. It's both crap and cloud. Yes, so multi-cloud auto-scaling demo. The setup that we're actually seeing, what's actually running here under the hood, is that, okay, I have a load balancer, which is the City Cloud load balancing service, running in Stockholm. I then have an agent that connects to the load balancer and asks it for how many requests per second do you have, or actually how many total connections do you have, and then it figures out, you know, requests per second because you just divide by time. Okay, so that figures out how the load balancer is doing. It reports that number into the monitoring database. From the monitoring database, the autoscaler figures out what's the current load on the system and does some math, right? And then it figures out, okay, I need 5 servers right now. So it tells this splitter thing to go get 5 servers. The splitter has a policy. That's why I defined the priorities between the zones, right? So it knows that, okay, this many, this percentage of the deployment should go to Stockholm, this percentage should go to Kuna, and then we have components here talking to each cloud using that API. Okay? Now, if you go on YouTube, we have a video where we scale between City Cloud and Amazon, so this doesn't have to be City Cloud, but since they're paying for our dinner, no, I'm just kidding. No, but we're actually very happy with City Cloud because it's a very fast cloud. It's very quick to get a new instance up and running. Very, very nice. If you compare it to Amazon, it rocks. So, this is what we're seeing. And going back to the question, this part, you could have your own agent running on each server, and then you just configure it to report into that monitoring database. Call the monitoring metric whatever you want, and then have the autoscaler pick it up and do its math magic on that. And yes, I've already said it's already running. So let's look at the monitoring database itself. And we have a bunch of requests. What does this say? Okay, so red here, I hope you're not colorblind because it's not very clear if you are. The red, the plateauy one here is the number of servers that we're running in the cloud. And the green here is the current load as reported from the load balancer. So we can see some kind of spike here. I suppose that's when I said, please go to cloudbeer.elastisys.com. I suppose that's when it was, because it spiked up a lot, which caused the autoscaler to react and say, oh, okay, wow, we might have a huge increase in traffic. So it takes a while before an instance is marked as running because, well, we request it first, and then when it's actually running in City Cloud, that's when we say, okay, I have it. If you have questions so far, again, please interrupt. I like that more than questions afterwards. The load is applied via script, as I said, but you definitely cannot see this, so I'm going to outline it with my finger. So we start off kind of small, and then we just go up, and then we go down again, and then up again, just so we see some kind of scaling up and down kind of behavior. Now, we're also under load, hopefully soon, from Apica, because I haven't seen it yet. We'll have to see. We have a limit on 100 servers, so it's going to be interesting to see what this looks like afterwards. By the way, thank you, City Cloud, for letting us run this. And by you, of course. So everybody can go in and rush this server a bit. Let's talk about failure handling. So what happens if there are errors? Let's think about types of failures first. Now, who here has ever written a software bug into their software? Thank you. At least like 30% are honest. What happens when you have a software bug, right? You fix it, and then you replace the software with a hopefully less broken version. If your hardware breaks down, what do? Swear a lot. After having sworn a lot, you replace it with new hardware. When your cloud fails, do you replace it with a new cloud?
Yes.
Yes, you do. You actually do. So, assuming...
Could you add the category load balancer failure?
With the current OpenStack load balancing service, no. Because the current OpenStack load balancing service is a non-replicated service. And that's a bit...
So it can fail and then you basically scream and shout and run.
If that happens, I hope you have some kind of alarm set up so that you actually wake a person up.
And know that you should run around and scream and shout.
Yes, yes. The running around is important.
It is a category, but it has no fallback position.
Yeah, not just going with the load balancing service that you can easily click and set up in CityCloud, which we were hoping to demo here. Of course, you can set this up using redundant load balancers. I mean, Google doesn't run on one load balancer, right? So you can do this. It's definitely doable. It's just there's no like fancy GUI way of doing it, and this is not the business that we are in, doing cool load balancers.
No, I'm fine with that, but that's why it doesn't get in like a category.
Oh yeah,
in your
definitely,
taxonomy.
definitely, yeah. You are completely correct. But going back to when a cloud zone fails, so say Kuna for some reason goes offline. I mean, there's a cable being cut off or whatever. You have redundant, yeah.
Submarines.
Yes, yeah, sure. Yep, all those. Very reasonable and plausible reasons for Kuna to go down. The autoscaler doesn't really care that Kuna went down. It still sees a certain number of users coming in and requesting access to your service, so it still wants the number of servers that it said before, right? I mean, it still needs X number of servers. So it's the splitter's job to figure out how to handle this. So after a while, it's going to determine, okay, this is not just a temporary like glitch. It's actually Kuna is dead. Oops. It's going to go in and provision substitutes from whatever zone you configured as a failover. So Stockholm in this case, that I showed in the demo here when I configured. So what's the substitute? Well, the splitter keeps track of which servers are actually supposed to be run in Stockholm and which are just there to replace ones that should be in Kuna, really, if Kuna comes back. So when Kuna does come back, splitter can just terminate the ones in Stockholm after they're up in Kuna instead. So for a short while, yes, you will have more capacity, you will have more servers running than you were supposed to, but on the other hand, you also had automatic failover that didn't have to wake up a systems administrator just because the cloud somehow failed, right? So this happens automatically. So if this autoscaling stuff interests you, your question might be, well, can I use autoscaling? What do I need, right? So there are some design principles that you need to take into consideration when you when you consider your app, basically. How well have you automated the setup of your application? Can the application start up all by itself, or do you have to go in and manually do something? Because you have to manually go in and do something, that means the application can't come up 3 in the morning when your system administrator wants to sleep. Okay? So servers are going to be coming and going at all hours during the day and night. It has to be completely automated. Hence auto-scaling, right? Service discovery has to be part of this. So when you start a server, if it doesn't tell any other servers that it's around now, what good does it do? It's like that tree falling in the forest when nobody hears it. I mean, if a server comes up, it needs to announce its presence somehow to some kind of registry at least. This is what we did with the load balancer. So when a server comes up, that agent thing that I showed on the slide, it's going to ask the splitter, hey, how many servers do you actually have? When it gets a new one, it's going to update the load balancer so that the load balancer knows that this server is available. Okay? This is an easy case. If you have like a replicated, clustered database, you probably have to also transfer some data around when a new server comes up. So that has to be automated as well. One way of taking care of all this is to have a service-oriented architecture. Now what that basically means is you run a bunch of components and you run them in isolated chunks so you can scale each type of component individually. So when you have more users coming into your website, perhaps you don't need to scale the database up, you'd rather have to scale the web server up, okay? You want to strive for statelessness, because state information makes a server unique in some sense. And if it's unique, that means you can't just go and kill it. You have to wait for it to remove its state or something. So if you have this shopping cart system in your web application, for instance, if you store that as state in your web server and a session can take half an hour, that means one user that doesn't come back and do like a logout or checkout or something keeps its state in your server, and you can't shut that server down. That's pretty bad. So you'd rather just push state away to somewhere where it belongs, like a database or a key value store or something, so that the web server layer, the application layer itself, is stateless. This is sometimes referred to as cattle versus pets, because pets are animals that you take care of and they have names and you care about them and you love them and you like cherish them a lot, whereas cattle is like, yeah, you have like tens of thousands of cows or whatever, and I don't really care that much about each individual one. One way of trying to get into the right mindset for autoscaling or for scalable applications in general is to try to have at least 2 of everything running at all times during development. Because if you can do 2, the step to running 3 or 4 of that component is much smaller than going from 1 when you made a whole bunch of assumptions that there's just this one database or just this one load balancer or whatever. Going to 2 is difficult. So if you always try to have at least 2 around while you develop your application, you're fine. Before closing up, let's look again here. Woo! Okay. Yeah, we've scaled up a whole bunch. Not a whole lot. There we go. Here's a good reason for scaling up. We had tons of connections coming in just a while ago. That's good. If you would like to talk about these issues, then please come and talk to us, either in person or via contacting us via our webpage or whatever. Closing up, the takeaway message here, with autoscaling, I offer you peace of mind and more time to focus on your service, less time wasted on managing servers. You get more resilience, you get better performance, even in the face of sudden usage spikes, and you get fault tolerance, even against cloud failure. And, as icing on the cake, you might also reduce your cloud costs. But again, I'd argue that peace of mind is much more important. The end. So, thank you.